Good day po everyone. I am John Michael J. Teves and I will be discussing more about trigonometric identities, particularly the sum and difference identities for sine and tangent. Learning objectives. At the end of the lesson, students can find the exact sine and tangent function values, write function as an expression involving functions of theta, and verify that the given equation is an identity. Sum and difference identities for sine. The cosine sum and difference identities can be used to derive similar identities for sine and tangent. In sine theta, which is equals to cos 90 degrees minus theta, replace theta with a plus b. The cofunction identity is sine a plus b is equals to cos 90 degrees minus the quantity of a plus b. And after that, we have to distribute the negative sign and regroup, which results to cos the quantity of 90 degrees minus a minus b. Then we have to get the cosine difference identity, which was discussed in the previous lessons. So the cosine difference identity is cos 90 degrees minus a times cos b plus sine 90 degrees minus a times sine b. Therefore, the cofunction identities or the sum identity for sine is sine a plus b is equals to sine a times cos b plus cos a times sine b. Now we write sine a minus b as sine a plus the quantity of negative b and use the identity just found for sine a plus b. Therefore, the definition of subtraction is sine a minus b is equals to sine a plus the quantity of negative b. And we have to get the sine sum identity, which is equals to sine a times cos negative b plus cos a times the sine negative b. Therefore, the even odd identity now is sine a minus b is equals to sine a times cos b minus cos a times sine b. We just not forget that the sum identity for sine is sine a plus b is equals to sine a times cos b plus cos a times sine b, and for the difference of sine identity is sine a minus b is equals to sine a times cos b minus cos a times sine b. The sum and difference identities for tangent. We can derive the identity for tan a plus b as follows. Tan a plus b is equals to sine a plus b over cos a plus b, which this equation is a fundamental identity. And then we have to get the sum identities of the sum and cosine identity, which is equals to sine a times cos b plus cos a times sine b over cos a times cos b minus sine a times sine b. After getting the sum identity, we have to multiply it by 1, which is 1 is equals to 1 over cos a times cos b divided by the 1 over cos a times cos b. Cos b, which is equals to when we multiply numerator times numerator and denominator to denominator, which results to sine a times cos b over cos a times cos b plus cos a times sine b over cos a times cos b divided by cos a times cos b over cos a times cos b minus sine a times sine b over cos a times cos b. And then is equals to sine, we have to simplify it. It is equals to sine a over cos a plus sine b over cos b over 1 minus sine a over cos a minus sine b over cos b. Therefore, the tan a plus b is equals to tan a plus tan b over 1 minus tan a times tan b. We can replace b with negative b and use the fact that tan negative b is equals to negative tan b to obtain the identity for the tangent of the difference between two angles. So, amo na ini. Tan a minus b is equals to tan a minus tan b over 1 plus tan a times tan b. Ibalik amo isa tag change ang sign na nga to sa sum identity for tangent. We must not forget that the Some identity for tangent is tan A plus B is equal to tan A plus tan B over 1 minus tan A times tan B. And for the difference, tan A minus B is equal to tan A minus tan B over 1 plus tan A times tan B. Here are some applications of the sum and difference identities. Example 1. Find the exact sine and tangent function values. We need to find the exact value of sine 75 degrees. Solution: sine 45 degrees plus 30 degrees. Ug sa una sa 45 plus 30 degrees, kung imo sa isa, i-add still 75 degrees sa gihapon. Ug sa tagsingod zaon kay we, para mahanap nato ang sine sum identity, which is equals to sine 45 degrees times cos 30 degrees plus cos 45 degrees times sine 30 degrees. Amo na sila ang sine sum identities. And we have to substitute the known values at the good table that we discussed during the previous modules. Aton my exact values and tanan 6 trigonometric identities as my 30 degrees, 45 degrees, and 90 degrees. For this, sine 45 degrees equals the square root of 2 over 2 times the value of cos 30 degrees, which is square root of 3 over 2, added to cos 45 degrees, which is equals to square root of 2 over 2, multiplied to sine 30 degrees, which is 1/2. Then we have to multiply the fractions and then add. Therefore, the exact value of sine 75 degrees is square root of 6 plus square root of 2 over 4. We also, here, we need to find the exact value of tan 7 pi over 12. Solution: tan pi over 3 plus pi over 4. Pi over 3 plus pi over 4. 7 pi over 12 can still be extracted to 4 pi over 12 plus 3 pi over 12. Ang the result niya pa 7 pi over 12. Since 4 pi over 12 can still be simplified, so therefore, masimplify siya sa pi over 3. Same goes with 3 pi over 12, which is equals to pi over 4. After that, we have to get the tangent sum identity, which is now equals to tan pi over 3 plus tan pi over 4 over 1 minus tan pi over 3 times tan pi over 4. Then we have to substitute the known values for each identity, which is tan pi over 3 is equals to square root of 3, and tan pi over 4, which is equals to 1. Since the denominator still has a radical symbol or radical sign, we still need to rationalize it para mawaya ang radical sign sa denominator. So we need to multiply it by 1 plus square root of 3 over 1 plus square root of 3. Ang i-multiply siya by numerator times numerator, denominator of a denominator using antong gani FOIL method kung familiar sa the FOIL method. So after performing the indicated operation, we just need to combine like terms. Is equals to 4 plus 2 square root of 3 over negative 2. Since this equation is still factorable, so we need to factor it out by 2. So 2 times 2 plus square root of 3 over 2 times negative 1. Therefore, the exact value of tan 7 pi over 12 rather is negative 2 minus square root of 3. Negative 2 minus square root of 3 is already written in lowest terms. Another problem that we need to find the exact value is sine 40 degrees times cos 160 degrees minus cos 40 degrees times sine 160 degrees. As you can notice, this problem is a sine. It's a sine difference identity. Therefore, here is a solution. Sine 40 degrees minus 160 degrees. Ininwa sine 40 degrees minus 160 degrees kay ang isa identity, ang isa more pag-expand sa isa kay atong problem to sine 40 degrees times cos 160 degrees minus 40 degrees times 160 degrees. Then after getting the sum difference identity, we need to subtract 40 and 160. So it is now sine negative 120 degrees. Even odd identity, so we obtained negative sine 120 degrees. Then we have to substitute the known values, which is sine 120 degrees is equals to square root of 3 over 2. Since it is negative, the final answer is square root of 3 over 2. Applications of the sum and difference identities. Example number 2. Writing function as expressions involving functions of theta. Sine 30 degrees plus theta. Solution. Sine 30 degrees times cos theta plus cos 30 degrees times sine theta. This is a sine sum identity. Then we have to substitute the known values for each identity, which is sine 30 degrees equals to 1/2 and cos 30 degrees is square root of 3 over 2. Then we have to add fractions. Therefore, the exact value of sine 30 degrees plus theta is equals to cos theta plus square root of 3 sine theta over 2. Another is tan 45 degrees minus theta. Solution. Tan 45 degrees minus tan theta over 1 plus tan 45 theta times tan theta. This equation is a tangent difference identity. Then we have to substitute the known values, which is tan 45 degrees is equals to 1. And then we have to multiply 1 times tan theta. Therefore, the final answer is 1 minus tan theta over 1 plus tan theta. Another problem to solve is sine 180 degrees minus theta. Solution. Sine 180 degrees times cos theta minus cos 180 degrees times sine theta. The value of sine 180 degrees is 0 and cos 180 degrees is negative 1. Then we have to perform the indicator operation and simplify, which is the final answer is sine theta. Example 3. Finding function values and the quadrant of a plus b. Suppose that A and B are angles in standard position such that sine is equals to 4 over 5, where A is greater than pi over 2 but less than pi, and cos B is equals to negative 5 over 13, where B is greater than pi but less than 3 pi over 2. Find each of the following. First to find is sine A plus B. To identify for sine A plus B it involves sine A, cos A, sine B, and cos B. We are given a values of sine A and cos B. We must find values of cos A and sine B then. Sine A plus B. Solution. Sine squared A plus cos squared A is equals to 1. That is a fundamental identity. Then we have to substitute the given values, that is which are stated in the problem. Sine A is 4 over 5 and cos A is unknown. So cos A ang may ato taghanap. Then we have to square 4 over 5, which is equals now to 16 over 25, and we have to subtract both sides by 16 over 25, which results to cos squared A is equals to negative 9 over 25. Since cos squared, so pwede pa natin sa i-take ang square root, so therefore cos A, the value of cos A is equals to negative 3 over 5. In the same way, kung nato isolve, ang sine B is equals to negative 12 over 13. Now we can find the sine A plus B. Sine A plus B is equals to sine A cos times cos B plus cos A times sine B. Amzaon ang sine sum identity. Then we have to substitute the given values sa ato tag-solve, which is the sine cos A and cos sine B. Ato tag-solve nato, and sine A and cos B which are stated in the problem. And then we have to multiply, and then we have to add, and Therefore, the value of sine A plus B is equals to 16 over 65. Another problem we need to solve is tan A plus B. Solution: tan A is equal to sine A over cos A. That is a tan sum identity. We just have to substitute the given values ato mga given above ato sa ato problem. Sa ato problem and ato sa solve. Sine A is 4 over 5 and cos A is equals to 3 over 5. Then we have to take the reciprocal of the denominator since it is the rule in division. So therefore, the value of tan A is equals to negative 4 over 3. For tan B, still tan sum identity. Oh, yeah. Then we have to substitute the values given above and then the division rule. We need to take the reciprocal and then the value of tan B is 12 over 5. That we have already now have the values of tan A and tan B, so we can now find the tan A plus B. Tan A plus B is equals to tan A plus tan B over 1 minus tan A times tan B, which that is the tangent sum identity. Then we have to substitute the given values at ato sa taas ato tag-solve tan A, tan B dato. And then we have to perform the indicated operation. And then we have to follow the rules of division. We need to take the reciprocal and then multiply. Then the value of tan A plus B is equal to 16 over 63. Last problem to solve is sine A plus B is equals to 16 over 65 and tan A plus B is equals to 16 over 63. Since the two identities are both positive, therefore A plus B must be in quadrant 1 because it is the only quadrant in which both sine and tangent are positive. Kay sa second quadrant, only sine and cosecant are positive. In quadrant 3, only tangent and cotangent are positive. And the fourth quadrant is cosecant and sine. Cosecant. Or cosine and secant rather. We already now proceed to verifying an identity. We need to verify the identity sine pi over 6 plus theta plus cos pi over 3 plus theta must be equal to cos theta. In order to solve for this, we just need to focus on the left side of the equation, which is sine pi over 6 plus theta plus cos pi over 3 plus theta. We have to get the sine sum identity first of the sine pi over 6 plus theta, which can now be visible in the next equation, and then the cosine sum identity, which is the cos pi over 3 plus theta, which is also visible in the next equation. And then we have to substitute for the known values at sine pi over 6, which is equals to 1/2, cos pi over 6 equals to square root of 3 over 2, cos pi over 3 is 1/2, and sine pi over 3 is square root of 3 over 2. And then we have to simplify. Then it already is 1/2 cos theta plus 1/2 cos theta. And then we just need to add it out, and then it answers to cos theta. Therefore, sine pi over 6 plus theta plus cos pi over 3 plus theta is equal to cos theta. It is checked. It is verified. That's all for this lesson, and thank you.